Here we have a set math problem. Okay, let's go to the question. The length of a side of equilateral triangle ABC above is 10. In the figure, ED is parallel to BC and DF is parallel to AB. If the ratio of DE to DF is 1 to 3, what is the perimeter of triangle CDF? Okay, our aim is to find the perimeter of the triangle CDF over here. Now let me consider the other information we have in the question, that is ED is parallel to BC. Okay, let me take the side ED. So ED is over here and BC is over here. These two sides are parallel. And also there is another information, that is DF is parallel to AB. So DF is over here and AB is over here. So these two sides are parallel. Let me mark them. Okay, since these two lines AB, the line segments AB and DF are parallel, we can consider this AC as a transversal, because this line segment AC intersects both the parallel lines AB and DF. Okay, since the two parallel lines intersected by a transversal AC, then let's consider the angle measure over here and here. These two are called corresponding angles. They must be congruent. And also let me consider the triangle CAB and triangle CDF. Okay, in these two triangles, the angle measure at the vertex A, the angle measure at the vertex D are congruent, and C is the common angle for both the triangles. So clearly the two angle measures in triangle CAB, that is C and A, are equal to the two angle measures in the triangle CDF. They are C and D. By angle similarity postulate, the two triangles, a triangle CAB and triangle CDF, are similar. Okay, so if two triangles are similar, they must be in the same shape. Already we know that the triangle ABC is equilateral triangle. Since the triangle CAB and CDF are similar, then the triangle CDF also must be equilateral. Equilateral means all the three sides of the triangle CDF must be equal in length. Okay, let me assume X as the length of one of the sides of the triangle CDF. Then this side also must be having the same length X. This one also must be having the same length X. Okay, now to get the perimeter of this triangle CDF, I need the value of X, which represents the length of each side of the equilateral triangle CDF. So once I get the value of X, I can add the 3 X's to get the perimeter. Now let me consider this particular piece of information, that is the length of a side of equilateral triangle ABC above is 10. So ABC is an equilateral triangle and the length of each side of this equilateral triangle is 10. So that is the length of the side AC is 10. Then what is the length of the line segment AD over here? To get the length of this line segment AD, what I have to do is I have to subtract this X from this 10. Then I am getting 10 negative X as the length of this line segment AD. Now let me consider this particular piece of information, that is the line segment ED is parallel to the line segment BC. Okay, here we have two parallel line segments ED and BC, and the line segment AB intersects both the parallel line segments ED and BC. Then the line segment AB is called transversal, and the angle measure over here and angle measure over here are corresponding angles and they must be congruent. Okay, now let me consider two triangles. There is a triangle ABC over here and the small triangle AED over here. For both the triangles, we have the common vertex A. That is, this is a common interior angle for both the triangles. Okay, now clearly in triangle ABC, let's consider the two interior angle measures over here and here. And these two interior angle measures are equal to the two interior angle measures in the small triangle AED. Since two interior angle measures of one triangle are congruent to two interior angle measures of another triangle, then the two triangles are said to be similar by angle similarity postulate. That is, a triangle ABC and triangle AED are similar by angle similarity postulate. Okay, already we know that ABC is an equilateral triangle. Since AED and ABC are equilateral triangle, they must be in the same shape. So triangle AED also must be an equilateral triangle. Already we know that the length of one of the sides of this small triangle AED, that is 10 negative X. Then what is the length of this side DE? So this one also must be having the same length 10 negative X, and this one also must be having the same length 10 negative X, because it's an equilateral triangle. Okay, now what I'm going to do is I'm going to consider this particular piece of information, that is the ratio of DE to DF is 1 to 3rd. So the ratio of DE to DF is 1 to 3rd. Okay, now we got the length of DE, that is 10 negative X. We can plug in 10 negative X for DE. Let me plug in. And also already we got the length of DF, that is X. Let me plug in equals to 1/3. Okay, now our aim is to find the value of x in this equation. For that we can do cross multiplication. So that is the numerator over here has to be multiplied by this denominator. Then I'm getting 3 times 10 negative x equals to this numerator 1 has to be multiplied by this denominator. Then I'm getting 1 times x. Okay, now we can distribute this 3 to 10 and negative x, and I'm getting 30 negative 3x equals to 1 times x is just x. Let me add 3x to both sides. When I add 3x to both sides, is negative 3x, positive 3x will cancel out. I'm getting 30 equals to 4x. And now let me divide both sides by 4. So when you divide both sides by 4, this 4 will cancel out. When I divide 30 by 4, I'm getting 7.5. On the right side, I'm getting x. Okay, now I got the length of, I got the value of x, that is 7.5. That is, I got the length of each side of the equilateral triangle CDF. That is, here we have 7.5, here we have 7.5, here I have 7.5. I just replace x by 7.5. Okay, now let's get the perimeter of the triangle CDF. Let me write the stuff over here, triangle CDF. Okay, now to get the perimeter of the triangle CDF, what I have to do is I have to add the lengths of all the 3 sides over here. That is 7.5, positive 7.5, positive 7.5. When I add them, I am getting 22.5. Therefore, the perimeter of our triangle CDF is 22.5.